In this video, I'm going to have a look at the measurement sequence that comes with the system and describe its operation. So in the measurement sequence, we've got several sections. There's a set measurements variables, there's a repeat for each measurement and repeat for each replicate. The idea here is that you set up a case statement that will allow you to select either calibration, measuring a single standard, measuring a single sample, or measuring a whole series of samples. And so if we execute the sequence, you'll see the case statement comes up here, and we can select one of these options to carry on with. I'm going to select standard. Okay, I'm going to say I want to enter the concentration or measure the standard with concentration 0. And for this instance, I'm going to say 0 replicates because I'm not going to run through the sequence, and so it'll just end the sequence. That shows how the case statement works, and the case statement is set up in this set measurement type subsequence. Various options are presented, and then variables are assigned a value of 1 or 0 depending on whether that particular option was selected. Once each of these option variables has a value, we can use those to set up conditions for a particular set of measurements. So if opt_cal is set to 1, then when we get down to the next one, if opt_cal is equal to 1, then this subsequence will be carried out, and the same for each one: opt standard, opt sample, and opt multi-sampler. In each of these subsequences, we set up various important variables that are needed to do that particular measurement group. So if we're doing a calibration, we want to know which port is the calibration standard set at. In this case, it's port number 5. We want to declare that the measurement type that we're doing is a standard, and so when we get to processing the data, we'll put the data into a calibration table. If here we'd selected sample, then when we get to processing the data would be placed in would be calculated to a concentration value based on the calibration table. Number of measurements is the number of times we're going to repeat this part of the sequence here, and that is equal to the number of standards that we have defined in the calibration table. Number of replicates is the number of replicates that the calibration table is going to ask for, and then the stock concentration is the concentration of the highest standard listed in the calibration table. All the other standards are created from that stock solution by doing a dilution as part of the sequence, and we initialize a counter called standard num. And so in a similar fashion, there are conditions for just doing a single standard, for doing a single sample, and for carrying out a sequence of samples from the multi-sampler. Then for each measurement, we're going to, so for the number of measurement times, we're going to execute this sequence here, which will set up certain calibration variables. So if we're doing a calibration, we want to know what volume, or which standard are we going to actually be measuring, what the concentration is of that standard, and therefore what dilution factor are we going to have to carry out in order to get that dilution. We give the sample a name. For the multi-sampler variables, we're going to give the sample a name and prime the sample before we do the measurement. In the dilutions variable subsequence, we calculate what the volume of analyte and volume of diluent is, and then we use all of those variables to now repeat each replicate of the measurements. In this particular method, the sequence to obtain a measurement comprises of aspirating the sample, aspirating the reagent, aspirating the sample again. So in this way we nest some of the reagent between two sample zones, and then we turn the direction of flow around and begin acquiring response from the detector. During this acquisition phase, the second pump is used to merge a second reagent in with the reagent stack that we've built into the detector, and while those pumps are running, we acquire data. Once they stop running, we end the data acquisition. Then begins the process data subsequence. In this sequence, we take a boxcar average of the data to smooth it out. We subtract the baseline, calculate the peak height, and then depending on whether the measurement type is a standard or a sample, we either add it to the calibration table and carry out the regression fit on the available data, or if it's a sample, we calculate the value, and saving that data to file not only puts it in the results table, but it also gives us a copy of all the data that was obtained during that run. Final step is to flush the holding coil and the flow cell so that we begin with a baseline conditions. When the number of replicates of a particular set of conditions have been completed, we go to repeat the next measurement. When all the measurements have been completed, the sequence ends with a beep of the speakers to draw attention to the end of the measurement. At any point, we can have a look at the entire sequence by right-clicking on the sequence, and then selecting Expand All, or we can contract them and then just open up particular subsequences that we're interested in. To run the sequence, we press the green arrow. If we need to pause the sequence for any reason, we press that again, and then when we want it to go, we press it a third time, and the sequence will continue either where we have positioned the cursor or at the point at which we paused it. The second button stops the sequence when it is running. The third button records the sequence. Any change that we make to the sequence will result in this field changing color, so we know that some change has made that has not been recorded back into our resource sequences. If we don't want to keep the change, of course we don't record it, but if that is a change we want to keep, then the record button is used. The X button clears the work sequence from the work sequence panel.